Hello everyone. So today we're going to continue on with the equation of the line, and we're going to have a look at simultaneous equations and how they kind of work with coordinate geometry. So again, this is stuff from the junior cert, but again, we're just reinforcing skills that we're going to be using later on in this chapter. So let's have a look at two equations. So here we have an equation of a line. Okay, everyone can see that, and here's another one. So listen, it's handy to do a bit of revision while we're doing this. So let's quickly find the slopes of these lines because it's always fun to do that. Remember, the slope of a line, if it's written in this form where x is positive, the slope of the line is going to be the negative coefficient of x over the coefficient of y. And the same here, it's going to be the negative coefficient of x over the coefficient of y. So they'd be the slopes. I'm just doing this just to get your practice levels up again. But the main question here is we need to find where these 2 points intersect. Now you could go through all the hassle, if you really wanted to, of plotting a graph, finding where the x and y intercepts are, and then find where the 2 lines cross. Okay, but as you know, my mantra life is too short, so we are going to try and do it using simultaneous equations. So how do we use simultaneous equations? Well, listen, it should be old hat 3e, but we'll just go through it again. So x plus 2y is equal to 1. Let's line them up underneath each other. 2x plus 3y equal to 4. Put a little squiggly line. Okay, so remember the trick here is to cancel out either the x or y value and solve for the other. Once you've solved for the other, the algorithm says just sub back into one of the original equations to find the missing variable. Okay, so you pick whichever one is easier. It's probably easier to go with the x's because you only have to multiply one of the lines in order to generate a negative that'll cancel. So I'm just going to multiply the top line by minus 2. That should generate a minus 2x, which will cancel and then allow me to solve for the y. So let's just rewrite that line. So I'm just going to rewrite this new line underneath this one, and then I can just cancel them out. So minus 2 times x is minus 2x. Minus 2 times y is minus 4y equals minus 2 times 1 is minus 2. So now I'm really just going to cancel these. So I will use a pencil to cancel. And I'm left with 3y minus 4y is a negative y equal to 4 minus 2 is 2. Now we can't have a negative y, so y is equal to minus 2. So what do we do with this? We substitute back into one of the originals and find the answer. So I'm going to substitute it back into the first one. So x plus 2 times minus 2 is equal to 1. X is equal, skipping ahead of myself. X minus 4 is equal to 1. X is equal to 5. That is not my answer. My answer is when I take the two of those and put them back together like this. 5, comma, minus 2, bracket. The amount of people who will just leave it like that when you're asked for the point of intersection, you must deliver the answer in coordinate form. It's as simple as that, lads. No ifs, ands, or buts about it. Okay? So I'm not going to waste paper. We're going to try another one here. This time I'm going to use my 3 seconds and you pause and try it yourself. Okay? So let's get going on one. Oh, here's a nice one. So we want to find we want the equation of a line that's parallel 3x minus y plus 4 equals 0 and goes through the intersection of 2x plus 3y equal to 12 and 3x minus 4y equal to 1. Oh, that's nasty. That one's a nasty one. That's 2 for the price of 1. So before I tell you to pause, let's just do a bit of strategizing here and let's try and develop some type of algorithm that we're going to have to follow to get this right. we want to find the equation of the line. So at some point, we're going to have to use the equation of the line formula. So that should be written down at some point. We know it's parallel to this. If it's parallel, then we can figure out the slope of it. Okay, because it should be the same. That slope should be the same of this equation slope because they're parallel. So we'll have that piece of information to go into the equation of the line formula. And then we need a point to use in that equation of the line formula. And we'll get that point by finding the intersection of these two lines. So I'm going to count down from 3, and then I'm going to give you a shot. 3, 2, 1, pause and give it a go. And we're back. Right. So, hope you got it right, but let us see, did you get it right? That is the big question. So, let's do the easy bit first. Let's write down what I know. Y minus y1 is equal to m on x minus x1. That's what I'm going to use. So I need an x1 and a y1. I can only get that from there. So I'll park that for a second because I know I can get the slope fairly quickly. The slope is going to be parallel, so it's the same slope. I don't have to do any perpendicular changing on it. The slope is going to be the negative x over the coefficient of y. So the slope is 3. So that bit's done. Now let's deal with this bit. Let's get these two lads lined up. Squiggly line underneath them. Ooh, decisions, decisions, decisions. Nothing here is easy, but because both of these are already in opposite, already, it naturally, to my head, just makes sense to just multiply the top line by 4, the bottom line by 3, and the y's cancel out. So the top line by 4, the bottom line by 3, and they will cancel out. So let's just do that. So top line by 4 will give me 8x plus 12y equal to 48. The bottom line by 3 give me 9x minus 12y is equal to 3. So cancel. 17x is equal to 51. X is equal to 3. Substitute the x back into one of the originals. So again, you should be able to do this. So I'm just going to do this in my head, do it in my head because life is too short. Okay. X is equal to 3. That gives me 6 plus what is 12? It's 6 plus 6. So y is 2. So the point I am looking for is 3, 2. Now, let's put them all together in our beautiful little formula. Y minus y1 is equal to m on x minus x1. Y minus 2 is equal to 3x minus 9. Bring everything to one side. So 3x minus y minus 7, I think, is equal to 0. That is my answer, and that is it done. Now, I'll be totally honest with you, lads. That's an honours junior cert question, a leaving cert ordinary level question, and it would never, in its right mind, appear on a higher level leaving cert paper. But you do need to know how to do it because everything there is a skill that will build up to a leaving cert question. If you cannot get through that, it makes it harder to make the next step viable. Okay, so let us try another one. I'm just going to drop this down a bit, zoom the function up a bit. Right, so, okay, let's go a bit crazier. Okay, L1. Line 1 is 3x minus 2y plus 7. And L2 is 5x plus y plus 3 equals 0. Okay? So everyone's happy with that. There's L1 and there's L2. Okay? The question, though, becomes we need... I'm trying to think of this one now. Yes. Find the equation of L3, which is perpendicular to L2 and passes through the intersection of L1 and L2. So when I get the intersection of L1 and L2, L3 passes through that line and it's perpendicular to that one. So again, it's the same as the previous one, except now we're not looking at parallel, we're looking at perpendicular. So let's think of our steps first of all. We need equation of the line. We need slope. How do I generate slope? I know it's perpendicular slope to this one. And in the previous video, we explained how to get the perpendicular slope. Okay, once I have that, then I need the coordinates to put in. How do I get the coordinates? Well, I'll take these two and I'll find the intersection point. That'll give me all the information to pop into my equation of the line formula, and that will generate an answer. Okay, so I'm going to pause, give you 3, 2, 1, and see how you can handle it. Okay, 3, 2, 1, boom. And we're back. So how are we going to do it? Well, let's start with writing down what we need to eventually end up with. We need y minus y1 is equal to m on x minus x1. That's what we need to make this work. Okay, the question is, how do we get it? Well, we need an x1 and a y1. That's a coordinate. We'll get that from the intersection of these 2 points. And we need a slope. And we're going to generate that right now because it's the perpendicular slope. So let's find the slope. So the slope of L2 is the negative coefficient of x over the coefficient of y. So it's minus 5. But the perpendicular slope to minus 5 is, well, what number multiplied by minus 5 will give you minus 1? Isn't it a positive fifth? So now let us work out the simultaneous. 3x minus 2y plus 7 and 5x plus y plus 3. Now, these are unusual in that the constants are on the left-hand side. Now, it doesn't make a difference. I'll do it this way. So you can see straight away the one to target to get rid of is this fella, okay? Because that's a negative, so I just need to double the bottom line, and it should cancel it out. So let's rewrite them. I'm going to bring this over to make it easier for myself, and that becomes 10x plus 2y minus 6. So they're gone. I've got 13x is equal to minus 13, x is equal to minus 1. If x is equal to minus 1, what would y be equal to? That's what we're really asking. So substitute it back in. If x is minus 1, that becomes minus 3 minus 2y plus 7 equals 0. Okay, so the question is, what number is going to generate something here to give me a minus 4? Okay, so it's obviously going to be a 2. So it'll be minus 3 minus 4 is minus 7 plus 7 is 0. So y is equal to 2. So we have minus 1 and 2. Let's pop them in. So y minus 2 is equal to 1 over 5 on x minus minus 1. Bottom left, top right, plus 1. I think it's x plus 1. And then rearrange. Plus 11. And there you have it. Okay? Cool. Right. So that's kind of where you know, I would say that's where the limit of ordinary level is at Leaving Cert, and that's where the limit at higher level is at Junior Cert. For you lads, though, you're going to have to step on from there. Okay, so let us step on, as the man says. So here's a little conundrum for you. Let's just take okay, there we go. See him? Nice little line. I'll call him L1. I want you to write down any. Okay? Any equation that has the same slope as L1. So you have to make up an equation, entirely different equation, but it has to have the same slope. Okay? So I'm going to give you 3 seconds, pause it, and you write down what you think would be any possible equation under the sun that would have the exact same. Now, it doesn't have to be the same equation, but it has to have the same slope. That's the important thing. Okay? the exact same slope. Okay, so I'm going to do 3, 2, 1, and then you write down whatever you think it's going to be. Okay, 3, 2. What? If that's positive, it's going to be the negative coefficient of x over the coefficient of y. So it's going to be 2 over 3. So basically, we want any equation where the coefficient of x over y will give me a ratio of 2:3. Okay, that's really what we're looking at. So I mean, you could just reverse things around. Okay, you could say minus 2x plus 3y plus 8 equals 0. That would work, because when I check this one out, I'll get you'd have to force everything to minus coefficient of x. So you could force it, but I wouldn't. I actually think you'd be minus the coefficient of x over the coefficient of y. I don't think I'd like that one personally. I think if you're going to do that, that would multiply everything. No, I think we'll go with something else. No, I don't like that one. Let me think of another one. Well, listen, you could cheat. Double everything. 4x minus 6y plus 16. So, isn't that the same thing? So let's just check it. Minus 4 over minus 6 is the same as 2 over 3. Yeah, that one works. Okay? So, and you could keep going forever. You know, you could find any amount of multiples of that'll work. But here's the rub. Okay. If one of these particular ones had the point 4 and 2. So imagine I wrote down another one. Let's go again. Let's double this one up. 8x minus 12y plus 32 equals 0. You know, I could double this up again. 16x minus 24y plus 64 equals 0. They're all going to give me the same. The question is, which of them will contain that point? So you could sub them in, or you could just go, that's x1, y1, 2 and 3 is the slope. So y minus 2 is equal to 2 over 3 on x minus 4. 3y minus 6 is equal to 2x minus 8. So 2x minus 3y. Okay. And this one is going to be, so 2x minus 3y minus 2 equals 0. That one works. There's another one. So I'm just same thing, but I've just changed the constant. So there's just another example of it working. Okay, so listen, I'm going to throw a few of these at you, and I'll see you tomorrow. Best of luck. Thanks a million.